Another important technique to understand is an idea of rethrowing an exception. Let's bring up our exception propagation diagram to discuss this idea, and let's assume that this method on top of the stack decides to throw an exception. So the exception object is constructed as new object, like this, and now we have our throw statement, which initiates the process of propagating this exception to the appropriate handler. So first we jump to method C, and here there is no try and catch. However, we specify that this method can throw an exception, so the propagation continues to method B. And let's assume that we do have a try and catch this exception. And so we have this catch block here where we can handle this exception. The exception object reference is given to our catch clause right here. So this will be the reference to this object, to this exception. So there may be two possibilities here to consider. That this exception handler in method B completely handles the exception. So this is a place where exception propagation terminates. We do what we like with this exception, and the program continues as normal. The second possibility with this catch handler is that it only partially processes the exception. In this case, the catch block can either rethrow the same exception for the calling environment to handle the exception, or throw brand new exception for the calling environment to handle it. So what it means is that because the exception object is still in memory, it can be rethrown by using another throw statement right here in this method. This technique is known as rethrowing an exception, and basically the new process of exception propagation will restart from this point on, and we will propagate this exception to the next handler, potentially handling it right here in the calling method A. And this is the syntax. So when we created this original exception object in our method D, now we got a reference to it in our exception handler right here in our catch block in method B, as we discussed on the previous slide. And now we can simply rethrow the same reference to the same object from this handler. And the second possibility is that we can actually discard this exception object and instead create a new one, right? And then throw this one from method B and allow exception propagation to take place, and the next handler will have a chance to examine this object to handle the exception. All this becomes useful when we have a complex logic or a set of business rules to deal with different types of errors where basically a catch block may catch the exception but unable to handle it, or a catch block may decide that the exception should be handled by the calling environment and decide to rethrow the same exception object or brand new exception object and let the calling environment, other methods, to deal with this error. The idea of rethrowing an exception may be especially useful when you're developing your own exception classes. So I'll open our next slide, defining our own exceptions, and it may be needed when a method requires an exception that is not provided by any of the predefined Java exception types. And there also may be the second possibility that built-in Java exception could somehow expose details of your method's operation, and you don't want to make it visible outside of your own library of classes. Defining your own exception classes is closely related to exception chaining. The constructors of the throwable class, which is the superclass of all exceptions in Java, allows exception chaining, which brings a way to connect a chain of multiple exception classes and allow the exception handlers to examine not one but a sequence of chain exception objects. So for instance, if we already have an exception which was already caught, and that's the original exception object, then we can construct our own exception object based on our own exception class and specify the cause to be this original exception. So this creates the chaining. Basically, then if we throw this custom exception object, then the next exception handler will be able to examine both of these. So let me show you an example on our next slide. Here we create our own custom exception class, which extends from exception, meaning that this is a checked exception, and add this constructor that supports exception chaining that uses the parameter which is the reference to the throwable object. And all you have to do here is just to call the superclass constructor and pass this reference to the next exception object. So this code throws an instance of my exception, our custom exception, by, for instance, catching the input-output exception and then immediately constructing the custom exception and passing the reference to input-output exception as the parameter, which of course will be passed into this constructor as the cause, and we call the superclass constructor, which will be basically handled by the throwable superclass in Java language exception hierarchy. So let's make an object diagram. So here we have our input-output exception. Okay, so this is the reference to input-output exception. So we construct another object like this. We pass reference to our constructor, so exception chaining will be handled by the throwable superclass. So somewhere inside this object there is a reference to this exception object, IO exception. So this exception object is thrown by this statement, and when we catch this exception, of course we get the reference to this object, and when we make a call into exception get cause, right, so when we make this call, this returns a reference to the chained exception object. Okay, so this is the method implemented by the throwable superclass, and as a result our catch block to handle our exception gets access to both of these exception objects using the exception chaining technique.